And welcome to another episode of Analytics Mindset. In this scenario, we will go on to how to connect to BigQuery in this case, but it could be any other data set. I'm just using BigQuery because it's becoming more and more popular. And it's also a very big software by Google. And how can we connect to BigQuery? Through SQL Alchemy is a very powerful Python package, not the only one, but it is one of the most popular and also powerful ones over there. For some introduction, BigQuery. There is a couple of steps that you may need to do in case you want to replicate this. Usually my tutorials have less of a content on you need to set this up by yourself and more do it on the go. But I'm trying to experiment with new content and this is one of them. To be fair with the disclaimer, you will need to have a Google service account. You can create one yourself. I do have by my employer BigQuery resources and a lot of other stuff that I cannot use for my personal use. That is why I just created my own service account and I am querying the BigQuery public data that is available for everybody. If you were in a work function in a current company, you most likely will need to first set up the BigQuery service, usually through an AD group, auto authentication, you will need to request that. Then you need to set up your project, or if there is a data set that you want to access, figure out which AD group or whatever your company does. It might just be an ad hoc access account where you are going to be authorized to query that data. None of that is going to happen here. Here, what I'm going to show you is the actual use cases of connecting to BigQuery through SQL Alchemy and the opportunities you may have from data analysis and data engineering. This is a very, very big step on data engineering. If you're interested in the career path, I strongly recommend you to start with this. If you're a data analyst that you want to pivot into data engineering, you are going to need more of this ETL / connect to databases through code kind of deal. With those disclaimers there, I will go ahead and show you through it. I created an account with my Google public account. And as you can see, I am in my free trial with BigQuery. That means I don't get charged anything. I have a query here. I will open a new tab so you can see it in the new query. I'm just going to copy this and paste it because I already executed it. BigQuery is a little bit different than other SQL tools that it tells you an estimation of how much data you're going to process through it, 8.63 gigabytes. This is what's called the BigQuery console. It allows you to query authenticating with your Google account. In this case, again, it's my personal one. If you were doing it through your employer, it will be the actual account there of your employer. And it's a very simple query. I'm using the Wikipedia table that has information on Wikipedia up to 2010, I believe, or 14. It is maintained by Google. It's a snapshot. It is not really up to date, and that's okay. You can see how there is a lot of data sets here. You can use whatever you want, but for the sake of this video, I'm just going to go with this data set in Wikipedia because it's something that all of us at some point have seen in some degrees. What I'm doing here is a very simple, basic SQL query that says the count of the distinct titles as the number of titles / articles. The contributor ID is who actually contributed there. This is by contributor, not by article created. Every time you need make an edit on Wikipedia. And I want to exclude minors. Why? Because I can. And it's just easy to know all the contributors that are not minors. I group by contributor ID, and then the number of titles needs to be more than 1,000 just to limit it so I don't get the results of every single contributor because Wikipedia has a lot of contributors. And then the other order by the number of titles, that is my alias. Some databases allow you to do this, some do not. BigQuery allows me to do it, I will do it. And descending, that means the first value will be the one with the highest one, then the second count, third count, etc. I will go ahead and run this. And you can see here how there is no actual contributor ID for all of these articles here. The second one is an actual contributor ID. If I want to, I can exclude this one as well. For this purpose, we will go ahead and assume this is the correct one. Why would I like to have this query on Python? By the way, there is tutorials to how to create the JSON authorization file that you're going to need to connect through SQL Alchemy in BigQuery. I will leave the instructions on the description. If you need help, let me know, and I will gladly go more over it or provide my help as much as I can. To not make this video that long, we will go then to the actual code. As you can see, I'm actually using Spider 6. This is a new version of Spider with my new computer, because why not? And we will connect to BigQuery using SQLAlchemy. You are going to need to install with this syntax pip install SQLAlchemy BigQuery if you do not, because SQLAlchemy comes with a lot of packages. BigQuery may or may not come installed depending on your environment settings. In case if you have an error, do it and just install it. We're going to install import two main packages, SQL Alchemy and Pandas, because that's where we're going to store our data later. We will get the dialect of BigQuery here. SQL Alchemy again allows you to do multiple things. You can go through a lot of different SQL Server databases. You can do through different stuff here. But for this point, I want to do BigQuery, and actually it's not working here. I will try this once again. All right, sorry about that, guys. Yes, miss one little part here on the dialects syntax. As you can see, SQL Alchemy does not have registry, but we can fix that really easily. The reason why I had that error is because a lot of times I will just adapt the code to myself. I don't really like importing part of a package, mostly because I have very small examples, and I come from a different school of thought where you can just import the whole thing. I prefer to import the whole package instead of parts of a package. Sometimes I just need to adapt my code a lot for that. Yeah, there you go. We have established the BigQuery dialect as our preferred dialect, and now we will need to create an engine. You will need to create this engine with your credentials path. I installed this, as you can see, in this JSON file here. And that's basically going to authorize you to be able to connect to BigQuery. You can see here how now I have a variable, that's the engine variable, is going to allow me to connect to BigQuery using SQL Alchemy. It's like me entering to my Google account and then saying, it's me. I am the one actually signing in. If you're curious, I'm just going to show you because I can here on my node, on the actual JSON file in my downloads here. And if you open it with Notepad, it's no different than any other single JSON file. It has your savings account and just the project ID. This is just a free project ID. And yes, you should not share this with other people, and you should never show it in like I'm doing this video. But again, this is just a very, very free. Even if you had this and the public and private key, there is really no risk because I most likely will either delete this key or just let it open if somebody ever used it, recreating the whole JSON file. The only thing they will get is the normal free BigQuery account because I don't have BigQuery set up for billing with my personal account. Now, after that, we're going to create a connection. The connection is created using this thing called Engine Connect. And you can see here how we have the BigQuery connection engine here. And from there, I will take the query here. And you can see that my query has been now created here. I will declare the query again. You can see how I have the query as SQL Alchemy text. I could pass it like a regular text, but SQL Alchemy is prefers that way. There is multiple ways to create this and pass the actual SQL query. The advantage of Python here is that you can create with the F string especially, you can pass variables into this query. You can do what is called a dynamic query. You are basically passing through those queries and you are passing a variable. let's say I have a list of contributors IDs that may change. I could put in the where clause where contributor ID in and then pass that list from Python into SQL. It is a very powerful tool with a lot of use cases that you could still do in the console. There is ways that you could do that, but the magic code is you can automate this stuff and have a script that then takes care of all of that for you. You can see this in this very small example. Now we need to store that result somewhere. I'm going to use a connection and then execute. That's going to create the result here. And then I'm going to print every single row here. But that's not very useful, right? I am just going to every single row and say, hey, give me everything that is in there, row by row, iterating. That's where pandas comes into place. We can use engine connect and then as connection, and then use pd read SQL query using our query and our connection. This is going to take that into a data frame. And in the data frame, you're going to have exactly the same values as you had in the BigQuery console. We are creating a data frame with all this data here. And you can use this data now to do your analysis and do whatever you want there. I can also just use everything we have done with data frames like DF had before. Now, my last recommendation is always close your connection, especially if you're automating this through either Airflow, Broadcom's Automatic, or other kind of tools, or just in a Windows Server schedule, being honest, because a lot of times that's just what works the best. You want to close the connection for a lot of reasons. The first one is privacy. What if somebody tries to get into your account by using that connection? There is attacks that can be performed, etc. It's just always good to close it. The second one is security. If your connection is open and somebody gets your connection, you might have a very big issue there. That's another thing to take into account. The last thing you want to be aware of is not closing your connection may cost you money, and that may be cost because you left your connection open. And guess what? Google still charges you. Google will take every trick in the book just to call it that way. BigQuery is a cloud platform. It will charge you for writing, it will charge you for accessing, it will charge you for reading, it will charge you for everything. You want to minimize your cost by having the least amount of data read, the least amount of data written, all of that in the shortest amount of time. With that, you will be able to not surprise yourself. I have an $8,000 bill from Google. It is not me, it's my company. Why is there this bill here? It will help you avoid any unexpected charges. And because I'm using a free account, I only have a certain limit before Google actually just stops my access. And that's why I close the connection. That's always good. If you are scheduling this somewhere, it will be good too, because every single time this Python script runs automatically, it will open a connection, do the stuff, then close it. And you don't need to worry about that. You don't need to worry about the connection just being hanging around somewhere or doing stuff like that. But all right, I hope you found this video useful. Please let me know if you have any questions. And yeah, have a very good day. And I will have a lot of more content coming on pretty soon. Thank you.